Welcome to adding and subtracting rational expressions. Today's objective is to add and subtract rational expressions and to simplify complex fractions. So here we're going to be adding and subtracting rational expressions. Now, in these two examples, it's pretty easy to add these rational expressions because the denominators are the same. So that means we're going to learn how to add when the denominators are the same, and we're going to learn how to add when the denominators are different. Now, for these examples, since the denominators are different, all we do is combine the numerators. So we have 3x minus 4 plus 2x plus 5 over the common denominator of x plus 3. Now, once we've done this, we can combine the like terms of the top, and we have 3x plus 2x gives us 5x, and minus 4 plus 5 is 1. And we have our denominator of x plus 3. Now we can't simplify this anymore, so this is our simplified rational expression. The second part of this problem asks us to identify any x values for which the expression is undefined. So we know that to figure this out, we want to figure out what would make the denominator, which is x plus 3, equal 0. Well, if x equaled negative 3, the denominator would equal 0. Therefore, x cannot be negative 3 because if it was, the denominator would equal 0. Okay, for problem B, same thing. These are easy to subtract because the denominators are the same. So we have 2x minus 1. Now we have to include this minus here, and we do 4x plus 4 over x squared plus 2. Now I put this minus here because I'm going to have to distribute that to each term in here. So I'm going to actually rewrite my numerator as 2x minus 1 minus 4x minus 4 over x squared plus 2. And then I combine like terms, and I have negative 2x minus 5 over x squared plus 2. That is my final simplified expression. Now I want to figure out what values of x will make this function undefined. So I do x squared plus 2 equals 0. Now when I try to isolate the x, I find that I have x squared equals negative 2. Now if I did take the square root of both sides to get x by itself, I would have x equals plus or minus I times the square root of 2. Now this means that the only numbers that won't work here are imaginary numbers. So I can say that x has to equal all real numbers. Once again, adding these rational expressions is a little easier because the denominators are equal. We'll see what happens when the denominators are not equal. So when we're adding fractions, for example, when we're adding 3 over 4 plus, say, 1 over 3, we can't add these fractions because the denominators are not equal. So this goes back to elementary school math. To be able to add these two together, we have to make the denominators equal. So we have to find the lowest common denominator. So for here, we know that 4 times 3 equals 12. So that's actually going to be our lowest common denominator. So if we're going to be adding up these two fractions, what do I have to multiply 4 by to get 12? Well, I have to multiply top and bottom by 3. And what do I have to multiply 3 by to get 12? I have to multiply top and bottom by 4. So when I simplify this out, I'm going to have 3 times 3, which is 9, over 12, plus 4 over 12. Now my denominators are the same, so I can combine these to be 13 over 12. Now this is a much easier version, but the idea is very similar for rational expressions. So now we're going to add two rational expressions that do not have a common denominator. So when we come onto problems like this, our first step is to find the lowest common denominator. So to do this, you take both denominators in their simplest form. So x plus 3 is already in its simplest form, but x squared minus 9, I can actually factor that out and make it simpler. I know that x squared minus 9 is the difference of two squares, so I can show that this is x plus 3, x minus 3. Now remember, we want to have two denominators that are similar by finding the lowest common denominator. So you have to think, would you change or add anything to this one? Or would you add anything to the second denominator? If you rewrite them, it's a little easier to see. This one's going to have x over x plus 3. But the second one, if you rewrite it with the factor denominator, is going to have the x plus 3, but it's also going to have the x minus 3. If I want to make these two denominators the same, what would I have to do? Well, what I would have to do is, I would have to take this x minus 3 and multiply it on the bottom and the top of this rational expression. So my lowest common denominator is x plus 3, x minus 3. So now let's see what happens. If I do out the numerator of this left side expression, I'm going to have x squared minus 3x over x plus 3, x minus 3, plus this negative 18 over x plus 3 times x minus 3. Now I can actually add these. So once I find my lowest common denominator, my second step is to distribute what's in the numerators, and then my third step is going to be to combine like terms. So when I combine like terms, I'm going to have x squared minus 3x minus 18 over x plus 3, x minus 3. Now we're not done here, because actually I can factor my numerator. There are two terms that I can multiply together to get 18 and also combine to get 3. So I need x's here. So 6 and 3 would give me 18, and 6 and 3 would also give me 3. I have to make sure this term is negative and this term is positive, and then I have x plus 3, x minus 3 my denominator. I know I can simplify by eliminating the x plus 3's, and my final rational expression is x minus 6 divided by x minus 3. Second part wants us to figure out any x values for which the expression is undefined. Well, we know that x cannot be 3, because if we plug 3 into there, we'd get 0. And even if we plug 3 right here, 3 squared is 9, 9 minus 9 is 0. X can't be 3, and also x cannot be negative 3. Okay, let's try a practice problem where we'll be adding two rational expressions. So our first step is to find the lowest common denominator. So my first one is x plus 3. Now my second one, remember I want to write these in simplest form. It's hard to see the comparisons between x plus 3 and x squared plus 6x plus 9. But we can factor that second denominator. We can factor that second denominator to be, I have x's here. I want two terms that'll multiply together to give me 9 and combine to be 6. So actually 3 and 3 work out. So let's rewrite these. So we have x divided by x plus 3 plus, and I'm just going to factor the numerator while I'm here, 2 times x plus 3. And then in the denominator I have x plus 3, x plus 3. Now technically we could eliminate these x plus 3's, but for the sake of this problem, let's try to find the lowest common denominator. So once again, think, is it easier to add something in the denominator here or to add something in the denominator here? My lowest common denominator is x plus 3 times x plus 3. So I want to take this expression here and multiply the numerator and the denominator by x plus 3. So I have my expression x over x plus 3. I'm going to multiply the bottom by x plus 3 and the top by x plus 3. Then I'll have my 2 times x plus 3 over x plus 3 times x plus 3. Simplify the numerator out, and I have x squared plus 3x plus 2x plus 6. I got that by distributing the 2 through to the x and to the 3. Since I've combined my numerator and my denominator, I know that I have a common denominator now. So I can simplify this expression to be x squared plus 5x plus 6 over x plus 3 and x plus 3. So I have x squared plus 5x plus 6 over x plus 3 and x plus 3. I can factor my numerator because I do want to cancel out these x plus 3 somehow. And I know that 3 and 2 will give me 5 if I add them, and 6 if I multiply them. So here I can cancel these out, and I'm left with x plus 2 over x plus 3. Subtracting is the same idea. The first thing you want to do is to find the lowest common denominator. So if my first denominator is x minus 2 times x plus 2, and my second denominator is x plus 2, I know that my lowest common denominator has to be x minus 2 times x plus 2. So this is what I want both denominators to look like. So I don't have to add anything to the first one. I can leave that as 2x squared minus 16 over x minus 2, x plus 2. But for my second one, my x plus 4 divided by x plus 2, what do I need to add to that? Well, I need to multiply the top and the bottom by x minus 2. When I do this out, I'm going to have 2x squared minus 16. I'm going to keep this negative out here for now because I want to distribute this first. And I'm going to have x squared plus 2x minus 8 all over my new common denominator of x minus 2, x plus 2. Then I'm going to combine like terms. So I'm going to have my 2x squared minus my x squared. That'll leave me with x squared. I have my negative 16 with my positive 8. So I'm going to have minus 8. And then I have my negative 2x here. All over x minus 2, x plus 2. So I can rearrange that and have x squared minus 2x minus 8 over x minus 2, x plus 2. I can factor that and have my x's here. I need two terms that combine together to be 8 and combine to be negative 2. So 4 and 2 will work. The 4 should be negative, 2 should be positive, and this will all be over x minus 2 and x plus 2. My x plus 2's cancel out, and I'm left with x minus 4 over x minus 2. So I think the hardest part of these is getting used to finding the lowest common denominator. Once you find the lowest common denominators and you distribute the numerators, the rest of it is basic arithmetic, factoring, and eliminating. In this section, we're going to be working with complex fractions. Complex fractions are shown right here in these three examples, and sometimes you have to be simplifying them, adding them, or subtracting them. Alright, let's work with this first complex fraction. Now, we want to simplify, but we don't want to get too confused here, so I'm actually going to split this up into two rational expressions. So we'll call this one part A, and we'll refer to this one as B. So the first thing we're going to do is we're going to add whatever's going on in part A. So in part A I have 2 divided by x plus x divided by 4. So to be able to add these, I can't because they have denominators that are uncommon. So I have to find my lowest common denominator. So between these two, my lowest common denominator is 4x. So if I have 2 over x plus x over 4, to make this side on the left be 4 over x, I have to multiply the bottom and the top by 4. For the fraction on the right, I have to multiply the top and the bottom by x. So then this becomes 8 over 4x plus x squared over 4x. Now I'm able to add these up, and part A is 8 plus x squared over 4x. So that's part A simplified. Now let's talk about combining this with part B. So now I can rewrite my entire a and b complex fraction as 8 plus x squared over 4x divided by part b, which is x plus 1 over x. Now this is the same as if I wrote this as 8 plus x squared divided by 4x divided by x plus 1 over x. Now we know that division is the reciprocal of multiplication, so I can actually write this as 8 plus x squared over 4x times x over x plus 1. Now it's just multiplying two rational expressions. So I multiply the numerators and see if I can cancel anything out of here. So I'm going to have x times 8 plus x squared over 4x times x plus 1. Now the only thing that cancels out here are the x's. So my final expression is x squared plus 8 over 4 times x plus 1. And that is the end of adding and subtracting rational expressions. Thank you. Take care.